Okay, in what follows, we will be looking at the comparison of the decision taken when using the NPV rule versus the internal rate of return rule. Okay, so we compare different projects with the two different rules, and the idea of the next slides, which complement what you have on the other material for this course, is to better understand, in what circumstances the NPV rule and the IRR rule will lead to different decisions. So we will see three scenarios. Two scenarios where one project strictly dominates the other, and one scenario where the two rules may lead to different outcomes. So we have two different projects, A and B, represented by the following cash flows. So the initial investment at 0 is minus I0 as before, and cash flow at time t is CT, and the subscript A applies to project A and the subscript B applies to project B. So if a project strictly dominates the other, what does that mean, strictly dominate? So one way of strictly dominating is to cost less and to bring more cash. So here's an example. A cost $5, B cost $5, but every period A brings $1 more than B. So whatever happens, A makes more cash than B for the same cost. If B were costing less than B, it would be even better. But in this example here, A strictly dominates B. So whatever, regardless of the discount rate we will be using to discount these cash flows, we always discount larger cash flows with A than with B for the same initial cost. So A will always produce a larger net present value than B. And since net present value falls as interest rate increase, and since A always has larger cash flows than B, it will take a larger discount rate to produce an NPV of 0 with A than with B. So the internal rate of return of A has to be larger than the internal rate of return of B. So in this case, A strictly dominates B. The NPV rule and the internal rate of return rule lead to the same decision in terms of selecting one of the two projects. So on the graph, this is what it looks like. So what we have here, 45 and 40, is the NPV of each of the project when the interest rate is equal to 0. So the blue curve is the NPV of project A, and the NPV of A when the interest rate is 0 is 45. So 5 times 10, 50, minus 5, 45. The NPV of B when the interest rate is 0 is the sum of all cash flows. The sum of all cash flows is 5 times 9, 45, minus 5, 40. And the red curve is the NPV of B for different discount rates, and the blue curve is the NPV of A for different discount rates. The NPV of A is always above the NPV curve of A is always above the NPV curve of B, which means the NPV curve of A will cross the horizontal axis at a larger interest rate than the NPV curve of B. Both curves converge towards minus 5 because both projects cost 5 to implement. Here's another scenario where one project strictly dominates the other. So both projects have the same sum of cash flows, which means both projects have the same net present value when the interest rate is equal to 0. But one of the two projects brings cash earlier than the other. So A brings its cash earlier than B. So the sum of all these 5 cash flows here is 45 for both projects. but A brings 13 at time 1, 11 at time 2, 9 at time 3 versus 999 for B. And then only at period 4 and 5 does project A bring less cash than project B. But because A brings more cash earlier in its duration, in its life than project B, A will be less sensitive to variations in interest rates, which means that the NPV curve of A will fall at a slower rate than the NPV curve of B, meaning that the IRR of A will be larger than the IRR of B. Okay, so here A brings more cash at time 1 and 2 than B. So the NPV of A here is less sensitive to increases in the discount rate, which means that it will fall at a flatter slope than the NPV curve of B, which means that for interest rates larger than 0, the NPV of A will always be larger than the NPV of B. Eventually, both projects converge toward -5 because both projects cost -5. And both projects begin at 40 because the sum of the cash flows of both projects is 40. But between R is equal to 0 and R less than infinity, NPV of A always larger than NPV of B. And because NPV of A is always larger than NPV of B, the NPV curve of A will cross the horizontal axis at a discount rate larger than the discount rate at which the NPV curve of B crosses the horizontal axis. So the IRR of A is also larger than the IRR of B. So these are two scenarios that you have to remember, in which case you are certain that the NPV rule and the IRR rule will lead to the same decision when we have to choose only one of two projects. Now here's an example where it's not clear what project to choose, and this depends on the size of the interest rate. So A and B are two projects costing $5. B brings back $9 every period for a total of $45 in cash flow over its life, while A only returns $50 at the end completely. So the sum of all cash generated by A is larger than the sum of all cash generated by B. But A will be more sensitive to increases in interest rates, because the only cash inflow of A is received at time 5. So the only cash inflow of A is discounted over 5 periods. So when R increases, this gives a bigger shock to the NPV of A than to the NPV of B. So in this case, NPV of A will be larger than NPV of B for small interest rates, but NPV of A will be smaller than NPV of B for large interest rates, which means that the internal rate of return of B will be larger than the internal rate of return of A. So the NPV curve of A here, as we can see here, falls at a much faster pace than the NPV curve of B, which means that the NPV curve of A crosses the horizontal axis at a lower interest rate than the NPV curve of B. So here, being less sensitive to changes in interest rates, B has a larger internal rate of return than A, which is more sensitive to changes in interest rates. But if the actual interest rate is low, then A is preferred to B. But if the actual interest rate is large, then B is preferred to A. So here's a situation where the NPV rule and the IRR rule may not lead to the same decision when we have to select only one project between two projects.